that will be better in this new environment than in that other environment. So the environment many times acts as a filter or a sorting device. But also other animals. If you are, if you're a member of a species that is the prey of, say, a tiger, if you're a zebra, say, and you're the prey of a lion, well, then the slower zebras will always get eaten first, and the faster zebras. The faster zebras, the lion will not even be able to chase and capture, but the slower ones will. Which means that whatever genes are responsible for speed, whatever combination of genes in a complex way is responsible for the relationship between the muscles and the bones that give you eventually a higher stride and a faster speed, those genes for slow speed are going to be removed from the population, and the genes for faster speed are going to stay, the lions acting as a filter for escape strategies and for other types of genetic bases that allow the prey to escape. And vice versa. If you're an armadillo that normally gets eaten by a coyote, but you happen to have stumbled upon a gene that makes your armor twice as thick, so that the coyote cannot really bite through it, well, that gene is going to start propagating. It's going to start propagating because coyotes won't be able to eat the armadillos with a thicker armor, and therefore they will get to have more children, and several generations later, all the armadillos are going to have the thicker armor. So, the formula tells us something about a dynamic. I'm going to tell you in what way this varies from Aristotle in a second. But let me just first tell you one thing. Precisely because we're not talking about genes, or we're not talking about natural selection here, this formula can be applied to anything that replicates and is subjected to a filter. And many times this word won't apply. Let me give you an example. Imagine that you're a dog breeder, and that you're in the business of selling different races of dogs to different people. And now you've read in the newspaper that all these rich people want smaller dogs because they can carry them in their bags or something like that. So you start, every generation you're going to be the filter or sorting device, and you start with a population, a small reproductive community of dogs that are of normal size and kind of hairy. You start crossing them, mating them, and every generation, every 5 years or every generation, you take the ones that are smaller and with less hair, and you disregard the rest. And then you just cross the smaller ones, less hairy ones with each other. In the following generation, you pick the ones that have even less hair and are even smaller, and let's say they have some behavioral property such as obnoxiousness. Well, several generations later, what you're going to get is a Chihuahua dog. Now, why would anyone breed a Chihuahua dog is beyond me. It's got to be some kind of psycho dog breeder, right? Some totally psychopathic, person that would come up with that horrible design with a little bark. And clearly, with the little legs and the freezing that they are always, and they are entirely non-adaptive. I mean, you try to imagine releasing a Chihuahua dog, in the wild, be free, Chihuahua dog, running in the wild. What is it going to do? Annoy its predators to death? Probably, because that is the only possibility just for survival. That everybody would just go like, what the hell? You're not an animal. Oh, yes I am. Oh, what the hell was that bark, man? So, this process can also produce non-adaptive outcomes if humans play the role of filter. I mean, a better example would be, hothouse flowers like roses. We have now directed their genes to produce a lot of petals because they look much better and more concentration of perfume, but they cannot reproduce by themselves anymore. You cannot unleash a rose in the wild and, be free, rose. It won't do anything. It doesn't really have the ability to propagate itself, because now it depends on humans for its propagation. We have created all kinds of species that are unable to evolve on their own because we have evolved them for ourselves. Yes?
This dynamics that you just explained, that has direction and variation and replication and everything, you just mentioned the dog breeder. Who's that in nature? The same?
Well, in nature there are no dog breeders, right? That's why most entities in nature are adapted. But, I mean, the equivalent of the dog breeder in nature would be climate, would be predators, would be parasites, would be availability of food, would be a variety of other conditions, but of course not a dog breeder who's making decisions that are conscious, right? It's only in the human case that you have, that is only in the human case that you can produce Chihuahua dogs. Chihuahua dogs would not emerge spontaneously, even in Superman's bizarro world, okay? You can imagine anything, the most crazy ecosystem in the planet, and you're not going to be able to find Chihuahua dogs there. Chihuahua dogs need a human pervert acting as a filter for them to come into existence. And because I'm Mexican, I'm particularly touchy about it. I'm particularly sensitive about the issue of Chihuahua dogs because they tend to depict us Mexicans as Chihuahua dogs. There is no way in hell a Mexican would have possibly bred Chihuahua dogs, okay? I know that the word Chihuahua is Mexican, but Mexicans, we would have liked a big, angry, mean dog, not like this little thing with the legs and the trembling and stuff like that. That is like an insult to us, which is why I have it again. I have it for Chihuahua dogs. Now particularly have become Hollywood stars and stuff. Okay, let's start with our comparison with Aristotle. Aristotle, famously, and his terminology is already part of our everyday language, he thought, well, we're going to think about animals in a particular way. The term animal is a category. The category is a genus. It's a general category. And then we subdivide that category by finding certain properties. For instance, animals that are quadrupedal versus animals that are bipedal, and among the quadrupedal, animals that have paws versus animals that have hooves. And by that process of division, we reach the level of species. Another term that he invented. So that difference between the generic and the specific, which is right now part of our ordinary language, we right now use it, right? Well, that's more generic, or that's more specific, comes from Aristotle. And the fact that the terminology has invaded ordinary language just shows you how difficult it is to get rid of it. But he was thinking of these things not in terms of a process that produces it, a process in which a population of various replicators is submitted to the action of a filter over many generations and yields these historical entities, but but conceptual categories. The concept of an animal, the concept of a species, and how the two are related by differences. And then he, at the very end, put organisms, or individuals. So his classification has three levels: the genus, the species, and the individual. Individuals are all singular, are all unique, and so what really matters is the level of the species and the level of the genus. Animal and human, animal and dog, animal and horse. And he said it is at the level of species that we find the essence. We find that immutable set of properties that has always identified zebras, that has always identified lions, that has always identified horses, that has always identified dogs. And that method of analysis, of course, lasted, as I said at the beginning of the class, for 2,500 years. So long that, as I just said, the words specific and generic are now part of our everyday language. We cannot even think about these things without using Aristotelian terminology. But what Aristotle missed was this. For him, when he identified a species, the most important thing was identify what all organisms belonging to that species had in common. In other words, for Aristotle, the most important thing was sameness.